All right. So I just really quick wanted to show you guys two things. First, I want to go over doing the list dot structures for covalent molecules and bonds because that's different. And I wanted to show you guys some chemical formula. So first we'll do um, covalent bonds that was covered last week. So if we're looking here, right, let's look at the ones that I assigned you. I gave you guys a total of 3 to work on. All right. So let's start with PBr3. All right, grab my pen. So PBr3. So phosphorus is over, you gotta find it right here, and bromine is over here. So now we have a nonmetal and a nonmetal. All right, so we know that's covalent, right? We're not going to transfer electrons by definition. Covalent means they're going to share them. So the process is still the same. They still want to be stable with 8 valence electrons. It's how they get there. It's just a little different. Okay. So if I take my phosphorus atom, right, and I've got 3 bromine atoms. So we figured out what type of bond we have. Oh, sorry, let me just erase this real quick. All right, let's try that again. So I have my phosphorus atom, and then I have bromine. I have 3 bromine. So let's fill in the valence electrons. So maybe this time you can pause it and go look yourself. How many valence electrons does phosphorus have? Okay. All right, hopefully you're back. And you figured out it has 5 because it's in group 5A. So let's go back. So I'm going to do it like this. It's kind of cheating because I kind of know where I'm going with this. But remember, we always distribute our electrons around, right? So we go 1, 2, 3, 4. That's how I have the pair. Right now, let's look at bromine. Bromine's here, so how many valence electrons? All right, pause the video. All right, it's in group 7, so that means it has 7. Each of these guys have 7 valence electrons. They all want to get to 8. Sorry, I should have filled one at a time. Point is, we get to 7 for each of these guys. Let's go over here. I'm going to do it like that. All right. Okay. So when atoms share electrons, they form a bond. All right. So if we count electrons, valence electrons around phosphorus 1, 2, 3, 4, and 5. We want to get to 8. We need to get 3. So if I draw a bond between these two, and these two, okay? So we count, this is supposed to be a straight line. It's called a bond, right? So we count the bond because they're each sharing an electron. Each of those lines count as 2 electrons. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus is now happy. It has 8 valence electrons. Bromine has 1, 2, 3, 4, 5, 6, 7, 8. Each of these bromine atoms are now very happy because they are stable because they have 8 valence electrons around them. So the other piece from last week was talking about VSEPR. So VSEPR is basically a concept where these lone pairs of electrons, remember, electrons are all negatively charged. Think about all this negative charge I have built up. This lone pair is going to push these atoms into this particular position so they have this type of shape. I don't expect you guys to memorize shapes. I want you to understand shape. Shape is important when we get back to chemical reactions. So just want you to understand the concept, right? That's it. Okay. That's out of the way. The other examples on here are relatively straightforward. So you're going to do MgCl2. So the step 1, figure out what kind of bond you have, right? Look at where the elements are in the periodic table. Step 2, what type of bond is that? And then look at your models. Look back at the previous video, right? Figure out what you're going to be drawing, right? So just figure these out. I think based on that short one I did, you should be able to figure it out. So let's go back up here and let's look at these guys, all right? So now we have to look at the formula. So I gave you this model which explains the formula. We asked questions about the formula. So you can tell just by looking at the formula itself, it doesn't tell you if it's ionic or covalent, but you can see we have these little subscripts, right? So it tells you that in every molecule of carbon dioxide, there's one carbon atom and 2 oxygen atoms, right? Same for sodium chloride. There's one sodium atom and one chlorine atom for each of those molecules. So now you're going to fill in this chart for the chemical formula. It's a really similar process to figuring out the structure. You want to know what type of bond it is, but then you're trying to figure out the issue of stability, right? If they're cations or anions, they're going to give up or gain electrons. So sorry, just erasing this in case we want to come back to it. So let's go back. So let's look at lithium and chlorine. Okay, if I look at my periodic table, I have lithium here in this first column and I have chlorine here. Okay, so this is going to be an example of what kind of bond. You can pause it, think about it. Okay, lithium and chlorine form an ionic bond, metal, non-metal. 1 valence electron, 7 valence electrons. This guy gives up 1 electron, this one gains. So if you want, you can just do your drawing, right? I think it's kind of handy. You don't have to do all the brackets, but if you're confused, you're just like, all right, got 1 valence electron here, got 7 here. Okay, well then I know that this guy's got to give up 1. So my formula, right, just represents how many atoms are in each molecule. So I just write it like that, LiCl. And when you're filling these in, if you want to fill it in electronically, I'm easygoing. That's fine. You go to Format, go to Text, and you want to do this little guy. If you want to just type the number in after, that's fine. I understand, what you're going for. But here is an example where we don't need it. So let's look at lithium and oxygen. Sorry. So lithium is here. It has 1 valence electron. How many does oxygen have? It has 6. All right. So let's figure this out. So we'll just keep that lithium there. Remember, I'm not doing the structure. I'm just doing the formula. It's going to be the same whether it's covalent or ionic, right? So I have 1 here, and I have oxygen. Oxygen has 1, 2, 3, 4, 5, 6. Well, here's the thing. I give up 1 electron, I only have 7. So I'm not stable. So how many lithium atoms do I need, right? It has 6. It has 1. That's only going to give me 7, right? I want 8. So I need 2 lithium atoms, right? That gives me 2. That gets me to 8, right? So when I draw the formula, I'm going to have 2 lithium atoms for every oxygen atom, okay? So let's look at another one. This time let's pick a covalent, carbon and hydrogen. All right. So here's what I suggest you guys do. use this as your benchmark to see if you're ready for this or if you need more practice. Go ahead and try and do it on your own. Pause the video, right? Step 1, look at the periodic table, figure out the type of molecule you have. Step 2, look at the valence electrons. That's the column, the group. And then step 3, try and figure out how many of each atom you need to get to that stable configuration. And then start it up again. Okay, sorry this video is so long. I just want to make sure you guys have practice. All right, carbon, and here's hydrogen. All right, nonmetals. Carbon has 4 valence electrons, 4. Hydrogen has 1. Remember, hydrogen is a nonmetal. All right, it's got that color. Now, hydrogen's not going to get 8 valence electrons. It can't. It only has 1 proton. It's going to be helium, so it wants 2. So it's a little different. Okay, so if I just draw these in, I've got 4 here, I got 1 here. Then I make my covalent bond. They're now sharing 2. So I have 1, 2, 3, 4, 5. Hydrogen's happy, right? Because hydrogen, 1, 2, we count these lines as 2. Hydrogen's very happy. So what do? What we do is we add another hydrogen, right? Now this hydrogen's very happy. He's got 2 valence electrons. Carbon's still unhappy. It has 1, 2, 3, 4, 5, 6. So we got to fill this in. That gives us 4. So again, you can use this structure to help you figure out what you need to do, you know, or you can kind of look at the periodic table and do it from a math perspective too, right? So the other thing I could have done is I can look at carbon, has 4 valence electrons. It wants 8, so it needs to pick up another 4 valence electrons. Hydrogen has 1 valence electron. That only gets it to 5, right? So you can make it a math problem too if that's easier, or you can make it a picture, right? And just kind of like fill it in until you have all these happy atoms. Hopefully that helps. Hopefully it's not too redundant. And if not, remember office hours. Those times don't work. Just hit me up by email. Remember from a video I did before, I'm not deducting any points for late work. Don't get stressed about late work. Try and stay on top of it. But remember, if work is late, the only requirement I have before I put it in Infinite Campus is that you do a one-on-one meeting or we have some sort of discussion. We can have it through another channel. If you're not comfortable talking with me, that's fine. I need to know where you guys are. That's why I made that change, because I'm not hearing from a lot of students. And it's hard for me to set the pace and make changes when I don't get feedback from students. I wish we were in class because I know we could do this stuff together, you know, over each other's shoulder. And that was a pretty comfortable situation, but it's just not the way it's going to be. So hopefully this will continue to work. All right. Talk to you guys later. Sorry for the long video.